So thank you, Stefan. I would also like to thank Peter and Marcy and all the organizers of this event. I think it's a great event, and I'm happy to have had this opportunity and the reason to come to Australia, which I wanted to do for a long time. And actually, I could not make it, so I'm very happy to come to this conference and be able to travel a bit and see some of the achievements that you've been doing. We are, as you will see in the afternoon, we are doing quite a lot of things in France, in Europe, and all around the world, but we are more specifically attracted by the capacity here in Australia to develop projects and to build, actually to build and to be organized to build, and it's something which I also wanted to say from how we look at you from Europe. We see here a very strong capacity, and it's very interesting, and I wish that in our countries we would take a little bit of your sense of maybe, let's say, business and being in the action, because to us it's something that we also lack a bit. We are a bit idealistic in our old Europe, a bit in our heritage too, and so I wanted to have this reflection on your work here, and so congratulations to all of you, and I hope this will continue, and that maybe in the next days I will also contribute, if possible, to some of the discussions on these questions of norms and standards, which is my presentation, this first presentation, because I will have two presentations this afternoon. So where are we in France on that? And the presentation I'm doing has been prepared with two other of my colleagues. It's something which is new, it's not really new, but it's something we really needed to reactivate, because this is becoming now a serious problem for further development in France. So what I will do is, for those who don't know CRAterre, I will just have a brief presentation of CRAterre, just some few highlights of what happened in the 80s. Talk of the evolution of the standard environment in France. What are today's efforts, breaks and perspectives, and probably some of the questions we'll see later. So why do we exist in France, in our region? I'm coming from Grenoble, which is the edge of the mountains, and the mountains are making so much alluvions, and this is what is being used for as the earth material. So we have about 1 million traditional buildings in the region, which were mostly built in the 19th century, 18th, 19th century, beginning of 20th century. So all these kinds of buildings I will show more later on. And in the 70s, a group of students of the School of Architecture in Grenoble, facing this period of the first oil crisis, was discovered this heritage, and they were looking at these buildings here. Just the mud was taken here and built there. You know, each house that we have here is just like a pool for the ducks, and you take it and you do it. So it was something so amazing to them that they decided to explore the possibilities, and they decided to fund CRAterre, 1979. And there's been a very strong evolution of CRAterre. The most important was in 1986, when we were recognized as a research center within the School of Architecture under the Ministry of Culture. So we are now a research laboratory. We have something extremely specific, maybe unique in the world, is that we have a postmaster course, which is a 2-year postmaster course specialized on earth and architecture. And based on that, we also have a UNESCO chair, so we are recognized by UNESCO, and the aim of this UNESCO chair is to help our students of the postmaster to develop training in their own universities for those who are linked with universities. We also have a strong specificity, is that we are not only a research center, we have kept the status of NGO, so we are both a non-governmental organization and a research laboratory. So the two are complementary. The NGO is working on the field and being able to be very reactive and provide services at different levels. When in the research center, we try to theorize and write down things, books, etc. So there's this kind of loop and feedback of different type of activities: research, training, dissemination, publication, and side projects, so that we don't talk of things we don't know, because we actually operate on the ground. Okay, and another important thing for us is heritage. As I started with it, we come from heritage, and we always feel that heritage is a very interesting and very important source of information for developing new projects. So thinking of the building materials, how things have been built, and with the idea of developing housing. Some of the things that we've been doing since the beginning is publishing. So the first one is this one, building with earth, construire en terre. This is the Traité de la construction en terre, which was later on translated in English, which still represents some of the basics documents which are used almost world over. I will come back to this later on. And in 1984-85, just when I joined CRAterre, there was a very interesting opportunity to make a demonstration. And by that time, what we've been using as a basis for doing this 65 flat project was to just describe what was the tradition. So the recommendations which had been established for the architects who made the designs was just look at the tradition and design. So this is how these buildings were designed and constructed. Another very important project, which dates back from the beginnings of CRAterre, is in the Mayotte Island. It's in the Indian Ocean, in the southeast of Africa, and we developed compressed bricks, stabilized compressed bricks for this area, and it ended in 20,000 housing units in Mayotte after having trained, having established brickyards, and worked with a developer which is called the Société Immobilière de Mayotte. So all this is always published, and we have documentation, and we have many publications. Unfortunately, still a lot in French, but all of them available on the web. So you can go to our website, www.CRAterre.com, and you can download many technical documents. So our aim also is to to develop information that can be used for people. So the evolution of a normative environment. As you've been seeing, we've been able to do a lot of projects and to help a lot of people to do projects. But today there's more and more breaks to the development of urban architecture in France. The first is there's a lack of knowledge. It means even though we publish, even though we provide the information, most of the technicians, the engineers who are in charge of projects, they have been trained to something different. So they don't know anything about it, and they are a bit scared. Sometimes there's a lack of data. So we have data, but there are some gaps in the data, and people are asking, of course, for those which we don't have. One other thing which people don't really like is, which we like, but they don't like, is the variety of raw earth, which entails scepticism and entails also the wish for making control. And control is something which is becoming terrible. We've been discussing this earlier on the issue of insulation of buildings and thermal efficiency. It's something which there's a lot of pressure on that, and people want proofs for everything and testing of everything, and it's something which is really new, and there's more and more pressure on that. So I think it's in France, but I believe it's with the discussion which have been happening this morning, I think it's world over. We also discovered that we had a seismic risk in France, which I never knew. When I was trained as an architect, I never knew there was a seismic risk. But it's very low, but we need to take it into account. So we need to have calculations for taking it into account. If we have buildings which are 500 years old, they are asking us, demonstrate why it stands here. So we need to demonstrate what we have been doing and what people have been doing. That's something which is really new. And there's also the evolution of the thermal norms. We had RT 2012, and we have now 2020, which is even worse, which is something, well, you don't know how you can build with now. Because the only thing is to build with insulating material, have 30 centimeter thick insulating material, and then that's so you have a cool box. Is the right name, cool box? You stay inside, don't breathe. Or just the little drops you have to be given. So it's something which is totally crazy, which probably is going to change, but it will take time to convince people that we need to change, because we need to breathe, we need to open windows, because I mean, you cannot stay in a cool box all the time. So and there are problems in houses which have been built recently. So there's a people are conscious now of this type of problem, which are created by these new standards. So we have a government which is conscious of the situation. But it's a paradoxical situation with some things which limits the development of alternative building methods, because you need to prove so many things before you can start. And finally, what is happening is that you encourage industrial products, which are themselves highly responsible for the production of greenhouse gases. So the strength we have is that from the experience of Mayotte, which I've shown earlier, we have standards on compressed earth blocks. So it's a national standard, though it's still experimental. So it's currently being revised, but it's something, at least this exists. A lot of work has been done on that. We have also some people who have gone a bit faster than the earth builders in France. Is the straw bale construction. They've been going fast. They have organized themselves very well, and so we have what we call règles professionnelles. It's like professional rules, like agreed between all the professionals in the country. We have also some standards on plasters on earth buildings, plasters on raw earth buildings. So this is something which is already existing. So mostly for heritage conservation, can you apply on the walls? So this is existing. We have also done a lot of work on clay plasters, because something which has been developing a lot recently. So a lot of work has been done. We had a European program on clay plasters, so you can find this, all the results of this project in the website, and for this one, it's also in English. We had also another European project which was called PROT, and this is a training objective. It's establishing syllabus for training which are common for all European countries. So it's something which also you can find on the web. You have these type of forms for different techniques. There's REMDUF, there's COB, and there's brick, all types of bricks, brick structures. So it's, what it says, it doesn't shows the content, it defines what people should learn. That's this level. There's a new project now going in more details in, I think it's in brick construction. So what is happening now is that for each project, we are asked to prepare a specific document. They call it ATEX, Avis Technique Expérimental. It's something that you need to bring to the National Center, Scientific Center, and they tell you whether it looks reliable or not. So we've been doing that for numerous projects. The problem with this is that it's costly. Just to organize the meeting to get the thing approved is cost like 5,000 euros, up to 10,000 euros depending on the complexity. So it's a lot of money, and you also need to prepare a document. But somehow what we are preparing with this is something that we can put together and have something which can become then normative documents. So we are currently preparing two documents. One is on compressed blocks. It's for Mayotte, so just realize that we've been not doing ourselves, but we've been making possible the construction of 20,000 houses. And today they have stopped this technology because there's no norms and nobody wants to sign anything. So we need to produce the documents to be able to do that. It's crazy, but well, we are doing it, and then hopefully it will be done, and then they can start again, which is it's not we who demand. It's people in Mayotte, they want to continue because it's good for the economy, it's good for the employment, and it's good for the proper use of local resources. Because we have problem of sand, we have problem of gravels in this island. So building with earth is one of the best way to solve these kind of environmental problems. And the second one is on Remdov. And we are beginning with something which is a bit difficult, is unstabilized Remdov. But somehow we have all this million houses heritage. So we think we are strong enough with this, and we know it, and we know how to define all the rules and regulations for each step of fabrication of these houses. Actually, this already works, even though it has not been gone through the whole process. I mean, the fact that we've been preparing a document which puts everything together in a very organized way has already allowed to convince some of the control bureau. And this project here, they've not asked anything, just the document that we have prepared already is being useful. Concerning the blocks, we've been going into a fire test. The reason is that if you don't do fire test, you don't have authorization to use these materials in public buildings. So you need, I think it's, you need 1 hour resistance to this fire test, which is quite crazy. It goes up to 1,400 degrees inside. So you see that there has been cracks here and water coming out. This water, which was shown this morning, which is gluing the clay, is extracted at this temperature. So it's something really very, very tough. The good news is that this wall standing for 3 hours and did not break. So we have got the maximum capacity, so we are authorized now And this is the proof of the load-bearing capacity in buildings which receive a lot of public. So it's something which is quite strong. It's costing a lot of money to do that. Just to give you an idea, 20,000 euro for the overall thing, but probably useful for the future. So this on the compressed bricks is already considered for use in another territory. It's French Guiana. French Guiana is north of Brazil. It's a small piece of land, not very small. It's a piece of land that we still have under the flag of France, where there's a project. They have fantastic laterite in this area. So they want to reuse part of what we've been developing, but there's also the idea to use it for the whole of France as professional rules. So this document is not fully completed. We just received some remarks by the center in charge of doing the validation of the document. They want more seismic calculations. Actually, Mayotte Island is prone to earthquakes, so this is quite normal. But they are asking for strange questions. How do we fix doors and windows, which was not sufficiently described? Of course, we know how to do it, and there's no problem for doing it. But they are asking more details on this. And the behavior and protection in humid rooms, how we render the inside, what are the different things, is something which we have not been developing enough. And what is really the most terrible is control process. They are asking, how do we control the fabrication of the blocks? How do we control the fabrication of a mortar? What are the tests? Who is doing it? Who is controlling? How frequently? So it's something really terrible, but again, we need to do that, and maybe after some time people will be used to it, and at least we will have something. So it's still a long way, but I will show later on there are some interesting opportunities in France, which I will show in the next presentation, which hopefully will provide the means to undertake complementary tests, because we lack some data. I was discussing with Paul earlier, the issue of shear strength. The connection between the brick and the mortar is something which is not really known. It has not been very much studied. So we lack information on this. So there are some gaps like this in the information, which somehow these people are warning us on these gaps, what we should do. The idea is also to build more links with different research centers. We are architects, so we are not the engineers. So we are trying to develop links with engineer schools so that this testing can be done, PhD works can be developed on these issues, so that we complement the information which we thought we already have. We know how to build, we know how to do things, but we don't have the data so that control can be made. Something which is interesting, which goes with what we do in France, but it's in the same line, is that something we face almost everywhere. When we are building in Haiti or in Nepal after earthquake situations, people ask you data. And what we do in these situations is we don't come with any different technique like this. We just look after the earthquake, what has survived. We describe it, and we try to develop out of what has been withstanding the earthquake. And it's very interesting. But when we develop designs taking this into account, again, we are asked calculations. And we don't have anything to calculate. Reinforcements, horizontal wooden beams in masonry walls, for example, which exist in Nepal. We don't know how to calculate it, and nobody knows how to calculate it. So we are developing with an engineer school in Grenoble tests so that we can have data, so that these things can be officialized somehow, and we can have some calculations on this. So long and big work to be done, but I think it's interesting, and some of the things that also might be interested also to share with some of the people present here. So